Okay. How's everyone else doing?
What are you teaching this semester?
Using this? I'm teaching this. Okay. We're waiting for two folks, I think. Anyone seen Sarah?
No. We'll hear it.
Hmm. Oh, I see. Okay. Okay. Sarah will be our LA. Which will be really helpful. I've never done this class with an LA before. I think it'll be much better. The class is basically gonna be broken into two sections, like a 30-minute lecture, and then a big old lab. And the basic idea is that we'll discuss some concepts and then we'll do the concepts. Okay. So we'll start with introductions. I'm Dr. Krismani, he, him. I study the atmosphere of Mars using spacecraft data. I got my undergraduate from UC Santa Cruz. I went to CU Boulder for my PhD. Then I spent 2 years at NASA in DC. I decided that I hated the weather and I came back to where the weather is awesome, except for sometimes when it's on fire. So I want to go around. I want to get to know all of you. Some of you I know, some of you are new, some of you I met earlier this morning. But if you guys don't know each other, you'll be working with one another a lot this semester. So why don't we start with your name, your preferred pronouns, your year, like when you're graduating, where you are right now in your career, and then what you want to get out of the class.
Technically a senior, graduate this fall, and um, I guess so you Python. You know, I only got senior tours. So.
Python, let's go. Okay.
I'm Kevin. I'm he, him. I also graduate in the fall, this coming fall. And honestly, I have like the most minimal knowledge of Python just from tools. And I would like to learn it like better.
Cool.
I'm David. I go by Ian. Um, I graduate not this spring, but the following spring. And what I like to get is that I like to acquire more Python skills and apply it to my research.
Cool.
My name is Elliot. I go by he, him. I'm also graduating in the fall. And yeah, my knowledge on Python is from tools and also maybe trying to just do basic scripts. That's
Okay. Yeah.
I'm Will. He, him pronouns. And what were the next questions?
Year. And then what you want to get out of class.
Fall 2026, probably.
Okay.
And I don't know if there's C++ in there, but from what I did of C++, I liked it because it's just so rigid.
Yeah. Okay. No C++. But if you know C++, you'll do fine. It's better.
David, Ethan, graduate this semester. I just want to learn quickly.
Cool. And so David and David, what's your last name? Mile? Maya?
Yeah.
Aguilar. No worries.
Of this year, I guess what I want to, all my photos are she, hers. What I want to get out of this class is just to learn how to code, like, and have better programming skills. My still reading.
Okay, cool, perfect.
My name's Alyssa, she, her. I graduated this semester and to also improve my programs.
Yeah.
Yeah, basically, and that's the program.
Good, perfect.
Saul Ethan, graduating, if all goes well, spring of next year.
Okay.
And just the same, I want to kind of learn how to integrate physics into the program.
Okay, perfect. All right, so you're all in the right class. That's great. And so very similar goals. So I'm going to hopefully try to align the class with those goals. We're going to break down how the class is going to work, and then we'll sort of talk about what the weekly setup will be. So if you've never taken my class before, or if you're just starting now, some people think of it as non-traditional. I don't. But of course, that's because I do it every year and you do not. We have some student help sessions that I haven't decided on a time for. So you can go ahead and let me know what your availability is. If you go into Canvas, you'll find this when to meet. This when to meet lives inside of this module, and it's right there. So you click it, you put in your time period that you have available, and then I will find student help sessions that work for everyone. Okay? Not everyone needs to be the same one, but just like accommodating as many students as possible. Let's go back to the syllabus. We're just going to walk through this really quickly. I am not expecting you to have any programming experience. If you have it, that's awesome. I will expect you to know the physics, and I will expect you to know the math. This says computational physics, but really what we're going to do is we're going to teach rocks how to think. Okay? And the very first rule about teaching rocks how to think is that computers do exactly what you tell them to. This is sometimes the hardest part. You will tell a computer to do something. You think you told it to do this, but you really told it to do that, right? And so sort of the tools here, what we're going to learn is how to go from our understanding, our cognitive understanding of the physics, turn it into math, take that math, turn it into a code, put the code into the computer, and make sure that there weren't any errors all the way down, right? Okay. Do you have the book? Do you know this book? It's on its way. You can do this. This is pretty cool. So there is this online resources location from Mark Newman, and he's very kind. He includes sample chapters. And incredibly, it's the ones we need. Okay, so the first one that you want is chapter 2. This is Python programming, right? We're going to use a lot of the sections in here. I would highly recommend, if you plan to use Python in the future, just get the book. Like writing in it, it's easier. You flip through it. If you have the PDF, there are PDFs that can be found online from places that I'm not supposed to tell you about. You know where to find them. Okay. We'll sort of briefly go through graphics and visualization. This really makes more sense when we're actually using it. A lot of the class, what we're going to do is we're going to present an idea and then immediately use it. Because if you tell someone how to do something, they won't retain it as much as if they struggle doing it. Okay? All right. This class, okay? Everyone understands how to find this? Okay, so that's the book. This is what we'll try and do. We'll try and do that in this type of a calendar. So that's me. This is the reading that I would like you to do today. Now, obviously, you haven't already done that, but ideally what you do is you do the reading ahead of time. And the reason for that is the class will work. One of you will choose to present, and you'll place your name here. And you will present to the class the topic of the day. Now, it's not like I'll just leave. I'll sort of sit up there and help ask questions and moderate anything that you don't understand. But the idea here is we really want to build your scientific communication skills as well. So if you just sit there and you just read, sometimes maybe you don't feel like you got as much out of it. If you can read it ahead of time and then be able to present it, you get to really understand it on a different level, right? And particularly if you're explaining to a colleague or another peer, right? We'll have examples that we do. These are examples like from the book itself. And then we'll have what are called pair programming exercises that we do in class during the lab section. And then there's this thing called homework. We'll do that too. Okay. All right. Questions so far? Okay. I said all this stuff. I said this stuff. Okay. We're going to be using something called CoCalc, which is a collaborative Python environment that's hosted online. Yeah.
Do you want us to have like a full like PowerPoint presentation on the chapters that we're supposed to present? Or
I expect you to have no PowerPoint presentation.
just straight up just out of the dome?
Yeah. So you're just going to have notes. So you're reading and you're writing down your notes, or maybe you're highlighting your book. I'll have the book projected on the screen and you'll be like, okay, go to figure 4. Okay, go to equation 63. Look at what it says here. This is blah, 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 right? You're giving a high level summary. You're not reading the text. You're reading your notes of the text. So I always find that some folks, especially if they don't really like giving presentations or it's their first time giving presentations, they will just read the text and they'll just summarize paragraph by paragraph. That is a waste of all of our time. Okay. What I really want you to do is to kind of just be like, okay, here's why we're doing this thing. Here's what we're going to do today. And here it is in this example where we use it. Right. And that way we kind of summarize the day before we jump into those concepts. Right. Okay. And we'll talk about why that's important later. We're going to use something called CoCalc, which is going to host Python. It is collaborative. What that means is that I will push out to you an assignment. You will type, and then I will grab it back from you and I can grade it. Okay. You can also work with one another. You'll need to do that in the pair programming where you're going to both share one computer and do the project together. You can, however, use something called Jupyter Notebooks or the Spider Integrated Development Environment. So these are IDEs. These are something that you use to basically interact with a language. This comes as part of something called Anaconda, right? So Anaconda, Python, you get it? Snakes. Okay. The reason that we like Python in this class is because one, it's open source. That means that it can be contributed to at no cost. So for example, we will start to use packages and libraries that are created by people without them being compensated by you. So it's free to download Anaconda. It's free to use Jupyter Notebooks. And this is a much simpler way of writing code because essentially what you will see, oh shit, no bit shot, huh? Ooh. Okay, Jupyter Notebooks are straightforward and we're gonna see them when we open this today. It's gonna have a little bar like this, okay? And you're gonna type whatever you want in here. And then the result is gonna be displayed in a box underneath it. And the cool thing is that you can work on this in sections. So traditionally in code, you have to run the whole code from start to end, right? You start here and it runs in order. Computer just reads it through. Jupyter Notebooks kind of allow you to put this piece and then do this. And then maybe you can do something else below it and that'll do something else, right? Input, output, input, output. Make sense? Okay, we'll see more of this as we use it. In the second part of today, you will download it for your computer or you'll download it on the machines here. And so you'll really be able to dig into it. What else? I think most folks said that they're Windows. Anyone Mac? No, no one Mac in this room. Okay. I said that. We use Canvas a little bit. That's where I'm going to put like anything that I create for you guys and host it there. But traditionally, a lot of the communication either goes through Slack, email, knocking on my door, right? All of your assignments are going to show up in CoCalc. So I'm not going to hand out a piece of paper that you write on, right? This is not a writing class. This is a computer class. Okay. Contact policy. Contact me whenever you want. If I don't respond right away, that's okay. If I don't respond within 48 hours, remind me, because I will have forgotten. If you contact me at 9 p.m. on a Friday, at least give me till Monday to notice. Okay. If you contact me at on Tuesday at midnight, that's totally okay. Don't feel bad about doing that. I will respond when I wake up, or if I'm awake, I'll respond. Okay. In class, there'll be a presentation. Okay. I will expect you to not create slides, but to summarize your understanding of the reading. Okay. That can include the problem. Sometimes we'll do the problem as a group. If you are explaining an example from the book, I highly recommend you do the example first, so you can explain how the code works in the example. Does that make sense? Okay. Homework is due Friday. Homework will be generally, a bunch of little pair programming exercises, and they're maybe more involved, or they maybe build on something we did in class, but they are judged on 4 criteria, and they are in decreasing order of importance. The most important thing, does it have an algorithm to solve the problem? Okay, that's worth 40%. Does the code run? That's worth 30%. Okay, so if you have an algorithm and it runs, you already have a 70. Yay. Okay, so how do you get the rest of the points? Does it give the right answer? How do you know that it's the right answer? Just because it runs does not mean it's right. Okay, so you have to be able to think, okay, at the end of the day, I am a physicist, so I can use my physics tools to see whether or not this rocks, are giving me bullshit, or if it's real, right? Finally, is the code written well? And we'll talk about how we write good code later on. Okay, that'll be like in a couple weeks. We'll introduce each of these concepts as we go. You're encouraged to work in pairs, small groups, or together as a class on the homework, depending on what you're doing. The only thing that I require here is that you give citations where citations are due. So if you and a peer worked on the homework together, just say you did that. If your homework is identical, if you copy and pasted your friend's homework, that's an F. Okay? If you worked on the same code, you have very similar algorithms, but you have different comments, you have different names for variables, etc., that show that you worked together but separate, that's great. I expect you to do that. Okay? Do not copy code from the internet. If you can find it, I can find it. And guess who understands it better? Okay. So I can see it and it's obvious. So just don't try. You have this wonderful thing called ChatGPT. This is a tool that really helps you learn to code. ChatGPT, not good at a lot of things. Doesn't know how many R's there are in strawberry. Right? Did you know that? You want to see? Watch this. Oops. Oh, that's pretty good. Must have learned. Let's try it again. What's a different word? How many R's are there in blueberry? 2 R's. Okay, it's gotten better. Let's ask a question. What color berry? What color is not found in berry names? Orange berry, good. Pink berry, that's the name of an ice cream, right? Purple berry, gold berry. Is this all of them? Green berry. Red berry is certainly not something that exists. Okay. So is it great at this task? It's good at this task. Why is it good at that task? Because people complained a lot. It is not counting. It does not know what it's saying. Okay? People use this as a Google result. It does not do Google results. It is a large language model. It predicts the likely outcome based on source material. So the reason that it got better at doing this is because people said you're doing it wrong. Right? And I'm sure I'll have to look these up because these are the ones that I used last semester. They fixed it in a semester, but for the whole semester, it didn't work. Right? Okay. And you want to think about this as like a colleague, someone who can really help you. It's fantastic for writing code. Okay. So let me show you how we are going to use this. Oops, I don't know how to spell Python. Python. Wow, look how pretty that is. So what did I do? I asked it very specifically to do a couple things. I said, write in Python a list that's sorted from largest to smallest. Now, you haven't yet become experts in Python, but you will, and you can then decide whether or not it did it right. You don't know what any of this means, but I'll show you some important features while we're here. Here we have some comments. This is it talking to us about what it thinks it's going to do. Okay. Then it has some important things here. This is a variable called numbers. And just like a vector, you have a box and then you have some commas separating the numbers. Okay. Then it has a function called sort numbers. And then it prints them. It has some words that's in the quotations and the variable itself in the sorted numbers. Right? And then it does it again, and it says, I present you the list with it sorted. So what we could do is we could copy this whole thing. I could put it into our Python notebook, and we could run it. And we could see if it works. What would we expect to see as the output?
We'll see the original list and then the array that's printed.
Right, exactly. So we'd see, hello, come on. We'd see the original list here, say the original list and all those numbers in a row. And then we'd see the word sorted list, and they should go, how should they go? Which is, can anyone do it? Yeah, 9, 6, 5, 5, 4, 3, 2, 1. Good. So it's always good to think about what you expect to get before you run it. Because if you get something different, there's an error, right? So this is really good for sort of small tasks. Do you want this to write your code from top to bottom? No. Do you want it to write small algorithms? Yes, perfect. Don't care. The important part is you are not learning to be programmers. You are learning to be computational physicists. So you have a very difficult task because you will not only start with needing to understand the physics, then you'll need to turn it into mathematics. Then you'll need to turn that mathematics into algorithms that can be run by a computer. And then you'll have to write them in Python. And then you'll need to validate that all those things were done. Okay? So that's why we like working in groups. That's why we like asking questions. That's why we're not afraid of using large language models to write code. These are not substitutions for your own learning. Okay? And most importantly, they will fail. Okay. Questions, comments, concerns? See how many things I've done? I do use it all the time. See? Okay. Okay, you will have a project at the end of the semester. It will demonstrate how wonderful you are. Okay? It's the full semester project. It invites you to be creative. It invites you to demonstrate your understanding. It can be associated with your research, but I typically prefer if it's kind of like different. But I don't want you to just do your research for the class. But you can be like, oh, it's inspired by this work that I'm doing. Usually at about 7 or 8 weeks, we'll start talking about topics that you might want to do. It'll be like a homework and a half. You'll do something fun, unique in code. And then at the end of the semester, you will present it to the class in like a 10 or 15-minute presentation. And that will take our entire like finals. You will get extra points for like cool. You get extra points for like great presentation. You get extra points for like, that was really hard. I can't believe they did that. Right? Okay. Questions so far? This is also why practicing talking is good.
They start next week on Monday?
Yeah.
If someone gives sign up to it.
Well, yeah, if you want to. The earlier you sign up, the better. Material gets harder as it goes. You will have to present a minimum of 2 times.
Would you like us to sign up for 2 times right now? Or just one for-
Don't do 1 and then 1, right? Don't put a second one until everyone has done 1, or at least like count ahead of time, right? Okay. And also this is going to move around a little bit. So let's say I keep just blah, 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 and we don't get through this, right? And it moves. Okay, fine. Then we'll do it on the next day, right? Or let's say you see these words like catch up in debugging. That's not a presentation. It's because I build in Slack. Sometimes folks have a harder time learning about this than that. And so I always build into the schedule slippage, okay? Sometimes in class, the only thing people want to do is figure out how the fuck this code works, right? Okay. There's a couple holidays where we had one Monday. Yeah. And then we have another one President's Day. Then there's spring break. And then way down here is the presentation. Cool. Okay. How will you get graded? Anyone taken a class with me before? Want to explain it? Is anyone just David? Yeah, Lucia. Okay, everyone else is new. Okay, you will not receive a number or a letter during the semester. That wasn't enough. No one gasped. Okay. The idea here is sometimes grades, especially in a big class, they can be not formative to your understanding. So you're just trying to get the right answer. You don't really care as long as you get the A, right? I want to like tear back those assumptions and think about collaboration, which is really, really important in the framework of this class in particular. You're going to be working with someone else. So some of the work's going to be there, some of the work's going to be yours, but it's your responsibility to try and learn the material even when they're typing, right? And vice versa. Okay, so when we talk about pair programming a little bit later, you'll see that it's not just be quiet for 30 minutes while someone else works, right? It's collaboration. To that end, I really want you to be thinking about like what it is you know and what it is you don't know, and then me trying to give you feedback on those things, okay? So we won't grade the individual assignments. I will just go through and I'll just add comments or like large points, like, you know, this section here, code was great up until this line. Can you figure out why, right? Because a lot of debugging is just what did I tell the rocks to do and why didn't they do them, right? Okay. We'll have one-on-one conversations about how well you're doing. You'll mostly be thinking about 3 different components in the class. Your computational skills, that is how well you are as a programmer. Your ability to take the mathematics and turn them into code, how do algorithms work, and then your overall achievement in the class. Are you participating? Are you preparing for class ahead of time? That type of thing, right? Okay. I want assignments done when they should be done. I understand that life sometimes does not accommodate that. My only rule is that if an assignment is late, you tell me before it is due. Okay. Any questions? Okay. Okay, well, let's see here. We already finished the half hour that I was allotted. Do we want to download computer stuff? Do we want to jump right into getting started in basic programming, or should we shift this all down? How many people have opened the book? How many people open the syllabus? How many people open Canvas? Okay, guess everyone? Okay, good. Okay. So first thing I want you to do is I want you to, if you haven't already, go into syllabus and get the Slack link, sign in for Slack there. And then what we're going to do is we're going to sign up for CoCalc. Okay. So the first thing I need to do, CoCalc, if I can spell, it looks like this. Yeah,
Go to Slack.
Slack. So if you go to, hold on. The first thing we'll do, we'll go into the syllabus. And down here, we see that this is a link. I'm going to click that. It's going to redirect me to this. And I'm going to create a Slack account with some email. You might already be in Slack. And if so, I just want you to transfer into the one that I'm about to show you.
Small question. Do you sign up with a school email?
It doesn't matter, whatever you're more comfortable with. Whatever you're more likely to like be able to sign into. Okay. And then I'm going to add a channel here. Create a new channel. Come on now. Oh boy. Yeah.
Maybe it's this. Yeah, you put a side. Is it, you know, is on syllabus?
Right here on the syllabus. Hello. Um, okay. So once you've done that, find me. That's my name. Send me a message with the email you just used. Okay. I should have edited it. Can you edit it? Like this? Okay. Did you send me a message? Will did. Let's go. Well, I'm going to add you. It's a private channel. So you have to send me the email and then I'll send you. I know that some of you have already signed up. So. Okay, good. Now we're getting there. So now the next step is please go here and create an account in CoCalc. Sign up. Okay. You're a student. I hope. Use that same email address, please. And that way, I only have to attach one email to both of you. Okay. Oh boy, that's a good question.
What is it?
Right, that one, and then you just want the P4
P4 600, or you, yeah, I think that any of the P's is just the class number.
Yeah.
Cool. You got it? You signed in? And you sent me an email, Slack with the same email? Okay. So, do you want this on your computer?
Have it at home, you want me to put it on?
No. It's fine. It doesn't need to be on there. If you want it at home, this is what it looks like. Anaconda. You can go to free download. You neither need to sign up nor sign in. We can get to that later. Okay. Whatever you want. Yeah. I can show you how to transfer files very easily. Yeah, I mean, you can do whatever you want. That's your own personal one. Anaconda won't speak to mine. So CoCalc and Anaconda, they're compatible, but they are not automatically updated. CoCalc, no matter where you open it, it's as though it's on your computer. So the files that you host on CoCalc, they live on CoCalc. It's like Google Docs, but for Python.
If I'm gonna work on here, do I download and find out?
No. We'll work in CoCalc.
Oh,
It's like for when you want to do your project, for example.
okay.
You might prefer to do your project in Anaconda because then you don't have to be like on the internet. CoCalc requires an internet connection, right? Because it's cloud computing. Okay, so let's assume that I'm signed in. Bada bing, bada boom. Hold on, let me hide this from you. Okay. Here's my account. Let's go to my projects. Oh, I haven't even started a project for y'all. All right. Oh boy. I'm gonna have to buy a license. Did you know what your Mac runs? Well, there's about this Mac. And they'll tell you the type of chip you have an Apple of
I was trying to open the site canvas, but Sanders is kind of hard.
Okay. Yeah, I'll email you the Slack link. Anyone else having this problem? Oh, look at everyone. Hi. Wait, where'd it go? Okay, has everyone, anyone who's not Elliot been able to, oh God. Hold on, let's put this over here. Can't read it all. Elliot, what's your last name? Is your last four for your student ID 1686? Let's go, baby. All right. Where? Oh, observation. Don't look at my calendar. Come on, boy. All right. So let's go here. So this is the projects. So I haven't set up the project yet. My bad. But you should be able to see something very similar to this, right? Yes or no? Okay, so you hopefully have signed in to CoCalc. It looks like this. Okay, and then what does it look like? So can we do like your projects? Or is it, what do you have on the top? Projects.
Nothing.
Okay, that's okay. Let's try this. I'm just going to show you what the space looks like. This will become live for you. So rather than buying a license, the license will be purchased for you, obviously. So if I click here, it has some stuff that looks very confusing. It'll be fine. Everyone will survive. Okay. Over here, you have Explorer. This is like file manager. You have like new. And so I can go in here and I can create different types of documents. There's a lot more functionality here than we will use. All we really need is this bad boy right here. Okay. And they have, of course, look at that little AI. Ooh, okay. So they have a little code generator. Helps you while you're writing. Can you help me write this piece of code? Okay. I would recommend starting here, just the normal one, and only really get into using the AI as a helper when you've started to understand the tool itself. Okay. Because it's sort of like building on what you know. Okay. Yeah.
Sorry, you said to directly message you. That's awesome.
Yeah. Yeah. Just send me the email that you just used. Okay. Wait, let's go back. Oh boy. Let's see, I've taught this a couple times. I want like a not, I want one without a license. How do I do this? It's been too long. Okay. I guess I could just start Python. Oh no, I can't. Big project. It has everyone's files in it. Oh boy. It'll give you all these warnings. Just ignore it. Doesn't matter. Okay. So here's the first thing that we're going to do. We are going to create a Jupyter notebook. Here's what it looks like. Yay. You can't do this yet. You will be able to do this once I have put you into the project that you'll have for this class. Let me just show you some of the basic functions and the buttons here. Okay. Up here, you have the word in, and then you have some brackets. The brackets have nothing in them. But if I write something like print, this is Mateo, okay? And then I do shift enter, it will take this input. It'll tell me which order. So this is the third thing it's done. And then it gives you an output. Okay. And then it'll ask you for a new input. I can, if I want to, I don't have to continue. I can go back and say, oh, no, this is not Mateo. Don't be silly. This is Dr. Krismat. Oh, I pressed enter. So what happened? Went to the next line. So if I go back, now I do Shift Enter, and now it prints it. Okay. Let's say I want to do these in opposite order. Okay, I can say, wait a second, I don't really like this. You go into, let's see, how do I want to do this? Oh yeah, here we go. Let's say I want to, come on, stop. I want to move this down so that this thing happens before this thing, right? I can just say, this happens first, okay? Now, one thing that you're going to notice right away is if I do that, I get error messages, okay? Computer doesn't know English. Computer knows Python. So specific words mean specific things. The word print is a function. Notice that the word print is, anyone have color sensitivity? An ability to see all colors? What color is this? Blue. That's a function. What color is this? Orange. Red? I'll go with red. Red means that it is a string. What that means is that it is text that will be taken exactly how it is written, not, for example, if there's a function or a variable within the string, it will not be computed. And I'm going to show you how this happens in a second. Up here, you'll notice this happens first. None of those mean anything to the computer. So it says, what? And it says what right here. It says in this line, I didn't understand what the hell you said. Okay. Let's try some fun things. We can tell the computer anything we want. So let's do this. We're going to use an equal sign. Let's make this equal to 5. Is that reasonable? We can do whatever we want, right? It's like x equals 5. But now it's the word this. Okay. Now let's make happens. Let's make it the number 8. And let's make first 1, right? Okay. So what happened?
Basically, use the words and language that you-
Yeah. So we said, okay, this now represents 5, happens represents 8, and first represents 1. But it didn't give me an output. We stressed? What? We didn't tell it to do anything, and it's a computer that can't think for itself, so therefore it will not think for itself, it'll do exactly what we tell it to do. So how do we tell whether it did what we expected it to do?
you could tell it's-
You could tell it to print, right? So let's ask the question. Okay, so let's go here. We're going to add a new box underneath it. I can insert the cell with plus, and I can do it above or below. I want to do it below. Okay, so let's ask it to print. And I want to know each one of those. Okay, so I could say this happens first. Anyone worried? Why?
oh,
Why do I need parentheses? I have parentheses here. Let's make it bigger. Let's make it bigger. C'est bon? What? Oops. Shit.
but, well, you wouldn't need the quotation mark, because then it would become a string. That's how we turn it is.
Yeah. So each one of these is a variable. And we're going to talk about this more in detail as we actually get into Python programming. But I just want to give you a very quick introduction into how we actually interpret the information, right? How we're going to test it. So what do we expect to have happen here? We expect this one to be. That's a good question. We don't know yet. What do we want it to do? Assume we did it perfect. Yeah, I should print out one number, which is, this should be 5, and then happens should be 8, and then the last one, 1. So now we can try it. We should always guess before we do it, and then we see if it works. Oh shit. What happened? I spelled this wrong, but it's this. There's no caps. Okay, so Python loves capitalization, and you will make this mistake. Guarantee it. Okay. So generally speaking, either capitalize or don't capitalize, but don't just switch it up. Okay. The letter I and the letter capital I are different things. So let's go in here and let's like learn also how to read these errors. It says name, which would be the name of the thing. And it says the thing this is not defined. It doesn't know what this is. So, okay, so we go in, we say, I know how to fix this. Bang. Now we're computing. Okay. Questions, comments, concerns. Okay. We're supposed to get through a lot more stuff today. I don't think we will. I would really like you to just start working on 2.2 today. And maybe I'll slide 2.2 and if and when into here for Monday. We're going to start thinking about how do we make computers do thinking for us. Computers make choices. So they respond to input output. They test if things are true or false. They test if things are bigger or smaller. They understand how to use numbers. They don't understand symbols, right? So we'll have to know how to convert our thinking, which can be very much like words like round or big, into things that they can understand, right? I say they, but it's rocks. Okay. I just did this with my other class. So if you were in my other class, you will not need to do this. But I am going to give you a concept inventory test so that I can understand where you all are before bombarding you with math and words. It's not a test. You won't be graded. But what I'm going to do here is I'm going to pass this out. I would like for you to fill out as much as you can. If you don't know something, write the letters DK, that is to say you don't know, instead of leaving it blank. You need to do this, but you don't need to do it perfectly, right? So you don't get graded on what's in it. I just need to get it back. Is that okay? Okay, and if you just did this in the other class, we can either chat or you're welcome to do whatever you want. Okay. How many people? 1, 2, 3, 4. No, 4, 5, 6, 7. Yeah. Yeah. On Slack? Yeah. Hold on.